Assalamu alaikum students, your instructor Abdul Rafi here. So we are back with the playlist on hypothesis testing. We'll continue with lecture number 5 this is, and we'll be talking about case number 2. Just to give a quick recap and prerequisite information, we have done already hypothesis testing for the discrete variables, binomial distribution and Poisson distribution, which were lecture number 1, 2 and 3. Based on that, and type 1, type 2 errors are also done. Now we talk about normal distribution. Lecture number 4 was based on case number 1, in which you saw a two-tailed test. We learnt about the two-tailed test, how to do the normal distribution, the z-test for the normal distribution hypothesis testing. Case number 1, quick recap, which we talked about it. In this video, we talked about lecture number 5 is all about case number 2. So what is the difference between both cases? And the example I'll be doing it will explain properly and clearly what is case number 2 going to be. Case number 1 was that the population variable, the x, the distribution was normal distribution already. The sample can be any size. It can be large or small as well. And the population variance was also known to us. That was, sir, case number 1. The variance was known, sir. And as we mentioned that the sample could be of any size. This is done in lecture number 4. Please revisit that lecture to understand better. Case number 2 is about the application of the central limit theorem, and I have got a perfect question to understand. A lot of time the examiner asks this, and we will be applying that as well. The central limit theorem application. Case number 2 is when the distribution, the x is not normal distribution, the sample size needs to be large. The sample size cannot be small. I'll just mention the key concepts of the sample size. Sample size should be n is greater than equals to 30. So this n should be greater than equals to 30. The sample size should be large and the population variance should be known. So case number 1 and case number 2 have one thing in common, that is the population variance should be known. That is the common part between case number 1 and 2. What is different? That case number 1, the question itself will be normal distribution, and in case number 2, the distribution is not normal. We have to make it any non-normal distribution, any non-normal population, we have to make it approximately normal distribution. That is only possible when n will be greater than equals to 30. The sample size should be large. Hope everyone got it. That will be case number 2. An application of case number 2, it's a perfect question. Write it down. This is from the October 2019 and paper 7 variant 2 normal distribution question of the hypothesis testing the z value. Let's read it and understand from the perspective that the heights are available of a certain species of animal. They have found to have the mean 65.2, and we have got the standard deviation. The mean is standard deviation is 7.1 and the mean is 60. So standard deviation is 7.1. Let's write down the information, and the mean is 65.2. What the researcher says, the researcher suspects that animals in this region are shorter on average than elsewhere. So animals are shorter in this region else than elsewhere. That is what the hypothesis testing will be. Please remember, this time the last question, lecture number 4, was a two-tailed test. This time we are doing a one-tailed test to make things understanding from all perspective. And in that also one-tailed test, we'll see what the question is about. I think it's a lower tail test. It's basically the testing for the lower tail, not the upper tail. Okay, so that's a one tail test, and we'll soon realize that it will be a lower tail test as well. So what the examiner has given us, sir, that the mean height is 63.2. We have the large random sample. The hint is here. As you can see, the person takes a large random sample. She takes a large random sample of n animals. So the sample is large of these species from this region we are taking, and the mean is 63.2, and then she carries out a hypothesis test, appropriate hypothesis test, in which we are getting the z value available to 3 decimal places. She finds that the value of the test statistic z is negative 2.182, which is correct to 4 decimal places. We have to get the 4 marks. Starting off, you have to make a necessary assumption. What will be that necessary assumption? So we have to tell the examiner whatever that necessary assumption is, and then we have to calculate the value of n students. Okay, that is, n will be the large random sample of the animals. So what will be that assumption? Students need to understand that this is case number 2, as I have written as well, because the sample size is large, the hint was there, and the distribution is not normal. As you can see, they haven't mentioned it that x follows a normal distribution. Usually the questions will mention if we have a normal distribution or not. The mean was given and the standard deviation was given. I'm going to use that, students. The assumption is that we are saying that the population variance is known. Okay, this 7.1, because it is available, so we have to use that. Okay, we have to assume that the standard deviation for the population is variance is known, which is case number 2, that we have to assume that the population variance is known, and that is what we are going to write. Tell the examiner that we are assuming that the standard deviation or the population variance, so standard deviation is 7.1 for this region. Assume standard deviation is 7.1 for this region that we have to do basically. Hope everyone got it. Assume standard deviation is 7.1 for this region. The next point is that you have to apply that z formula, the z test formula, which is basically, sir, that the z value is x bar minus the mean divided by standard deviation. Since we are doing it for the hypothesis test of a normal distribution, that should be the formula which we have to apply, that x bar minus the mean divided by standard deviation divided by square root of n is equals to z value. Just solve this and have an understanding that let's use of the calculator will be implied, that we have minus 2.182. This is x bar, the testing value is 63.2, the mean is 65.2, sir. 63.2 divide minus 65.2 divided by standard deviation 7.1 divided by square root of n, which we are trying to get what is the number of observations, what is the random sample of the animals that we are taking. So you multiply, start multiplying and solving it. It will be, sir, minus 2.182 multiply by 7.1 and divided by the square root of n. This is all about calculation, so it shouldn't be much problem to understand this. We have got n in the denominator. This is equals to, sir, 63.2 minus the calculator 65.2. I got negative 2 here, so I can change the places after multiplying. Minus 2.182 multiply by 7.1. I got, sir, negative 15.4922. This will be divided by n. This will be divided by minus 2 because square root of n will be coming here. Sir, square root of n, I placed it here, students. And then whatever the answer comes, divided by negative 2, I'm getting 7.7461 is equals to square root of n. And when you square this on both sides, you put the square, sir. So when you square this on both sides, it will be the n value coming as that. When you square this answer, this is coming exactly, the random sample is 60. So the best thing is that the random sample, students, the large random sample, we are testing on 60 animals, and based on 60 animals, the mean that came out, the height that came out of those 60 animals, the test value was, as we talked about, there is a test value which is 63.2 here. The statistic value is coming, the z test statistic value is coming minus 2.182. Hence we have got the first 4 marks of this part, because the major part is how do you carry out the hypothesis testing at a significant level, how do you carry out the hypothesis testing at this significance level, which is worth 3 marks. Let's understand how the marking scheme works for this. Definitely 1 mark for the assumption, whatever the assumption you are going to tell. 1 mark for the n value, sir. 1 mark we get for the final answer, which is 61 mark for the test value, and the remaining 2 marks are for just solving and getting them correct. That have you done the calculation correctly for the n value, have you multiplied properly, divide properly, cancel out the negative. So as much working you will show to the examiner, the more marks you are getting, students. For part A, this is telling us that, as you can see, the requirement also matches. Case number 2 is basically about that the number of samples should be greater than equals to 30, which will this we can call it that the sample size is large, and we can easily say that from any non-normal distribution we made it that the random sample will become now a normal, approximately normally distributed as well. Moving forward, we have part number B of this question, case number 2 of the hypothesis testing for the normal distribution. We have to carry out the hypothesis testing, students, at the 4% significance level. You always start hypothesis testing with the step approach that I told in lecture number 1, that this is worth 3 marks. Mention the null hypothesis, that the null hypothesis is that the mean is 65.2. okay, the null hypothesis is 65.2. You can also mention the variable as well, that x is basically the heights of the certain species of animal. Let's also write that for understanding of the students, that x is equals to heights in centimeter of certain species of animal, heights in centimeter of certain species of animals, and we are going to make it normal distribution because of the large random sample size. So certain species of the animal. So what is going to happen, that the null hypothesis will be that the population mean is 65.2. As I mentioned that we are doing it for the one tail test, which is the lower tail. We have to check whether the heights of these animals are shorter in this specific region or than elsewhere. So heights are shorter, so we call that our alternative hypothesis will be, sir, the alternative hypothesis will be that the population mean or the mean is less than 65.2. That is what the understanding should be, that the mean is 65.2 and null hypothesis, and the alternative hypothesis should be that the mean is less than 65.2. This is step number 1 always. The next thing is that you have to get your test statistic value, which is minus 2.182. We already got it. No need to solve it, because that's why it's only 3 marks less marks, because the mean height was 63.2. We already did that the Z table, and we have got that the test value, the Z test statistic value is going to be the Z test statistic value. In this case, the only our answer matters, our conclusion matter. The Z test statistic value is minus 2.182. that is what we have got. And now we have to understand from the perspective of the normal distribution of these Z test of the hypothesis testing, that you have to reject, what's the case, reject the H naught. When do you reject H naught? You have to reject H naught if the Z value is less than whatever your significant level is. So let's try to get that significant level first. So let's try to, step number 3 or step number 2 should have been the significant level. 4% means the probability is 0.04. So the Z value will be coming for that, which is 0.96. The Z value will be coming 1.751. You can have a look at the table. If someone struggles with that, I'll just show them. You can't get the Z value for 0.04, but you can get it for 0.96. So here we go, 1.7. The Z value is 1.75, and you add 1 in it. Students. You got it to 0.96 as the probability. The Z value is 1.751. So here we go. It will be that you will reject H naught if your Z value is going to be less than 1. Your Z value should be greater than, in this case, reject h naught if your z value is greater than 1.751. So this case will be reject h value, that is 1.751. So I will be looking at the positive side of it. That will be that we have minus 2.182, so it will be 2.182 is definitely greater than 1.751. So you will have to reject h naught if the z value is, the test value is greater than 1.751. So that will be that this case is solved here, that this will be, sir, reject h naught. There is sufficient evidence, or there is enough evidence. There is reject h naught. There is enough evidence. Reject h naught if there is enough evidence that the mean height of the animals are shorter. Alternative hypothesis is accepted. There is enough evidence that the mean height of animals is lower. Mean height of animals are shorter in this region. Okay, so there is enough evidence they are shorter in this region. That is what we have got, and that is why we are rejecting the null hypothesis and accepting the alternative hypothesis, students. I hope everyone got it, that the 3 marks working will be, 1 mark will be for the population getting the null and the alternative hypothesis, 1 mark for checking whether the test statistic value lies in the critical region, acceptance, or the rejection region, and 1 mark is for the statement, the conclusion, whether you have to reject or accept h naught with the understanding of a statement as well. So that is what we have got 3 marks for. Make sure to have any questions, please ask in the comment section. And the last part that will give us 1 mark, the reason we did this question is because we have to explain why it was necessary to use the central limit theorem. We have to explain the examiner why it was necessary to use the central limit theorem in carrying out the test. The reason was simple, that the population was not given as normal distribution. So we have to tell the examiner that the population distribution was not normal. The population distribution was not mentioned. The population distribution was not given as normal distribution. Just have to make a statement, was not given as normal distribution. That is why we have to apply that the random sample size was greater than 30. As you can see that n was 60. So normal was not given as normal distribution. 1 mark liner will give you complete 8 marks for this question. Hope everyone got it. Case number 2. Stay tuned for case number 3 as well. And another important learning of more important concepts of the hypothesis testing will be done as well.